Vectors.
All about vectors. Our presentation will explain the basics of vectors. So, what is a vector?
A vector is anything that has two defining characteristics. One of them is magnitude, which is the size or quantity, and the other is direction, where the vector is directed from one place to another. Two vectors are equal if they have the same direction and magnitude, which is length. The vector is represented normally with an arrow. So, what are vectors useful in?
Vectors are useful in many things. In math, we use vectors and learn about them in geometry. We use them in jobs like aerospace and environmental engineering, also in medical and atmospheric science.
So, how do you solve a vector? The direction is the angle of the vector along the horizontal line, and the magnitude is the length. If you have the initial point, which is the starting point, and the last point, which is called the terminal point, then you can find the magnitude by using the distance formula or the Pythagorean theorem. So how do you go about solving a vector? Or what ways do you solve a vector?
Solving vectors. There are many ways to use vectors in equations, including adding or subtracting, finding the magnitude or direction, and finding equivalent vectors, and more. We will be focusing on finding equivalent vectors and finding the magnitude of those two equivalent vectors.
So when you're finding equivalent vectors, you have to look at the two vectors or more that you have. In this case, we have vector W, which is represented by blue, and vector U, which is represented by purple. So are vectors U and vectors W equivalent, or do they have the same direction and the same magnitude?
Are vector U and vector W the same? Vector U points to the bottom right corner, while vector W points to the bottom left corner. So, because they have different directions, vector U and vector W aren't equivalent. Okay, so we know vectors U and vectors W directions aren't equivalent, but are the vectors U and vectors W's magnitudes equivalent?
We have the vectors here again. Here you can see that vector U goes in 5 and down 6. So you can say that the change in x, or the change in how it goes in, is 5, and the change in y is -6. So if you use the Pythagorean theorem to solve that, you can say that vector U is equal to 25, which is 5 squared, plus 36, which is -6 squared. And when you use the Pythagorean theorem to find the answer, you take the square root of the sum of the two. So vector U is equal to the square root of 61. Now when we look at vector W, you can see that it goes in 5 and down 6. So the change in x would be -5, and the change in y is -6. So you can say that vector W is equal to the square root of 25, which is -5 squared, plus 36, which is -6 squared. And again, since we're using Pythagorean theorem, we're going to find the square root of the sum of both. So vector W is equal to the square root of 61. So we can see that the magnitude of both of these are equivalent because vectors U and W have equivalent magnitudes, which are the square root of 61. So even though they have different direction, they have the same magnitude.
What did we learn? Vectors are anything with magnitude and direction. Vectors are represented with an arrow. Vectors are equivalent if they have the same magnitude and direction. You can find the magnitude of a vector using the Pythagorean theorem.